So for international folks in the audience, we have a course in the United States called AP Statistics, where high school students can take a college-level stats class, and if they pass the exam at the end of the year, they get college credit. Nationally, about 60% of students pass the AP Stats exam year after year. However, in the urban core of San Antonio, where I teach, that pass rate traditionally hovers at about 2%. People in our schools wondered why. And to me, as a high school teacher, the answer was blatantly obvious. I crack open a textbook and start reading out a problem like this one. Factory claims that its batteries can recharge in 60 minutes on average. To test this claim, a statistician gets a random sample of 30 batteries and finds, just like that, heads down the desk, bored out of their minds. And I didn't blame my students. My students are mostly from low-income backgrounds. They're working jobs outside of school. They're supporting their family. They have complex, real adult problems on their shoulders. And the problems I were giving them was contrived and infantilizing. So at first, I tried to make more quote-unquote relevant problems like this one. On any given day, there's a 10% chance that a citizen of Wakanda required the help of Black Panther. In a full year, students quickly picked up that these problems had the veneer of relevance, but it wasn't actually using mathematics to explore a context in a way that gave new insight into that context. So I got really frustrated, and I walked into class one day and I asked my students, what do y'all actually want to learn about? They told me they want to learn do social media creators on average make a livable wage? So we talked about that using confidence intervals. How many people lie in their online dating profiles? Turns out a lot. And we talked about that using probability and expected value. Does income determine your access to healthy, fresh foods? We talked about that using linear regression. Does my vote really matter? We talked about that using sampling distributions. And when we went all in on fully relevant lessons for every lesson of AP Stats, my classroom got up to a 42% pass rate on the AP Stats at the end of the year. And note, this is not my accomplishment, this is my students' accomplishments. They're the ones who worked really hard, so those applause are for them. And here's a quote from one of my former students, Julius. I want you all to take just a quick read of this. So this class became a very powerful experience for students that could catalyze changes in their trajectory. And then the pandemic happened, and I was teaching online, not loving teaching online, and so I decided to make a website. I created a website called skewscript.org, put a bunch of these AP Stats lessons online for free. Now that website has 20,000 teachers that have accounts on it. We have had over 300,000 lesson downloads, and we now have expanded not just in AP Stats, but to offer free, relevant high school curriculum for Algebra 1 and Algebra 2 as well. And the results have spread too, not just in my classroom, but in May of just this year, a group of researchers from Harvard looked at the effect of the launch of Skew the Script on AP Stats scores across Texas. What they found is that Skew the Script has a causal impact on AP Stats scores. Our curriculum boosted pass rates 10 to 11, oh, thank you. Pass rates boosted about 10 to 11 percentage points on average after 2 years of use. And as far as we know, this is the first ever research or curricula showing causal impact in AP Stats, which has been offered in US high schools for almost 30 years now. But, and this is a big but, I got lunch with Julius a couple years after he went off to college, and he told me, sir, the class was great, but I wasn't ready for exploring raw data. In AP Stats, you learn how to do a one sample t-test for mean, a two sample t-test for mean, a one sample z-test for proportion, two sample z-test for proportion, chi-square test for goodness effect, chi-square test for independence, all these tests. And then a student gets a raw data set and they have no idea what to do with it. He was not prepared for, in his college classes, handling big data. He was not prepared for coding, which we don't even touch in AP Stats. And certainly he was not prepared to handle machine learning, artificial intelligence, and learning about that topic, which of course we do not also touch in AP Stats. And if you look at the structure of the course, it makes sense. Semester 1 is all this really cool intro stat stuff. Semester 2, it's inference, 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 inference. P-value, 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 confidence interval, go. And it's all these things that you have to learn, and we learn them at a very procedural level because there's so much to get through. You end up using your TI-84, as we call them, TI-1984 calculator, to do these inference procedures. And students walk away from their first ever statistics class thinking that statistics is about applying formulas to get p-values from pre-printed summary statistics about small data sets using their TI-1984. That's what statistics is. So we tried to expand the scope a bit. First, we tried Jupyter notebooks locally on machines. But I don't know why y'all work in K12 schools, the vast majority of K12 schools use Chromebooks, which only have online capabilities. You can't download anything locally. We also considered using Google Colab, but it does not meet K12 privacy standards. In a lot of schools, it's completely banned from being used. We tried DeepNote, but as soon as students have to make an account for anything that they have to use, districts will either ban it or will have an crazily credible IT process to get approval for it. And you have to then go to the company and request their specific data approval on their specific district thing, and companies don't have time for that. And it's crazy. And no teacher has the time to make that actually work if students have to actually have a login. Well, if we try Jupyter Hub, so the districts make their own accounts for their own students, right? So they don't have to worry about the data privacy agreements. It's too difficult to set up for most schools. Most schools don't have the IT infrastructure to make that happen, IT capability. So we needed a platform that is web accessible, works on Chromebooks, free to access, runs without any account. You can run code without making any account, satisfies the K12 data privacy requirements, and makes the student work easily shareable.
And so we started looking at applications that currently work in the classroom. I'm pretty sure a couple of you, maybe hopefully all of you, have heard of Desmos. How many of you have heard of Desmos? Yeah, it's great. It works great. You can access it in the web. You can create a link for your calculator, insert it into your lessons, and share it with your students, right? And then your students are able to access that link and play with it and engage with their education. And so we also thought about something that is currently available on the browser, which is Jupyter Lite. Many of people in the room, specifically Jeremy, who helped develop this, should tell you all about it. This is great. It's basically Jupyter on the web browser, right? And so we started thinking, well, what if we combine Desmos with Jupyter Lite, right? Would that make a great application for the classroom? And so that's where our journey began to develop Jupyter Everywhere, or something that we like to call Jupyter Everywhere. We still need approval. Whoever's in the room that wants to give us the approval, that would be great. But anyways, we focused on this journey to develop Jupyter Everywhere about a year or two ago. And so Jupyter Everywhere is a Jupyter Lite extension that works in the browser and is simple enough for students to access. And basically, you can you don't have to install anything, or you do not have to create accounts, right? So we take away a lot of the barriers of having to deal with school policy and so on. And so the core design goal of Jupyter Everywhere was that we wanted no installation required and no sign up. We also wanted to create shareable links, and we mostly wanted to focus on K12 education. And so we wanted to focus on having a friendly interface for first-time users. And so, sorry. Why is it not? There we go. This is a demo of
This is Jupyter Everywhere, a simplified web-based version of Jupyter Lite, built to make data science education accessible to everyone. It runs entirely in the browser, with no installation or accounts required, and comes preloaded with popular scientific libraries for both Python and R, including NumPy, Pandas, SciPy, Matplotlib, scikit-learn, Tidyverse, and Neural Net. Teachers and students can open a Jupyter notebook, write Python or R code, and share their work instantly through a link. With one click, we can generate a shareable link. This means teachers can create example notebooks and share them with students, or students can share their work with classmates just by sending a link. When someone opens the shared notebook, they can view it in a read-only mode. If they want to edit it, they can make their own copy. This makes collaboration safe and simple. If you want to start from scratch, you can create a Python or R notebook right from the homepage. You can also upload an existing notebook from your local files using the Upload a Notebook button. Let's open a new notebook and write a bit of Python code. This is what your notebook interface looks like. Our design approach keeps the layout minimal while adding friendly icons and a warm color palette. This makes the application less intimidating for students, while still allowing them to learn notebook behaviors that will transfer seamlessly to professional Jupyter tools in the future. We decided to keep the notebook panel buttons that users already know and love, but added some dialogue behaviors to make the experience more intuitive for first-time notebook users. For example, the replay button now displays a dialog box asking, "Would you like to restart the notebook's memory?" This helps prevent teachers from spending half the class explaining what a kernel is. Small design choices like this can save teachers a lot of valuable class time, while keeping the notebook approachable for students. Now that you're familiar with the interface, let's create a simple data science notebook. We'll explore a classic data set, analyze it, and visualize the results, all in the browser. We'll start by loading the Iris dataset. You can use the File tab on the left sidebar to upload local CSV files, or even image files directly into your notebook. Once the file is uploaded, we can use pandas to quickly load the data. You can also install additional Python or R libraries directly in the notebook, using simple command line commands. Next, let's do a simple analysis. We can calculate the average petal length for each species using just one line of code. Now let's make a simple plot to visualize the data. We'll create a scatter plot of sepal length versus sepal width using matplotlib. When your analysis is ready, you can generate a shareable link, make a copy, collaborate with others, or even download your work as a Python notebook file or as an HTML report if you want to save it locally or on a drive. Jupyter Everywhere is powered by WebAssembly, meaning all computation runs locally in your browser, not on a remote server. Our backend, built with a lightweight API, handles sharing links and notebook metadata using cloud storage. Jupyter Everywhere brings the power of open source data science to the browser. No logins, no downloads, just learning.
And so when we build Jupyter Everywhere, we mostly look to create small changes that would be impactful in the classroom. And believe it or not, sometimes kids really want to know what a kernel is. And sometimes teachers don't really know because a lot of the times they have top-down policies. So administration is kind of forcing them to teach data science and somehow, some way start teaching kids about machine learning models or data science. But a lot of the times they do not have the support needed or the tools required in order to start integrating these topics into the classroom. And so our vision for K12 is that we should expect that every kid is able to engage and wrangle with real-world data exploration, right? So we want to reduce the technical barrier that a lot of teachers and students might have to go through in underserved communities and underfunded schools. And we want to have the structure available for us to build curiosity and critical thinking within data science topics in K12 education. And so we believe that Jupyter Everywhere is an application that can be easily introduced into the classroom and would be able to help solve for many friction that can happen from wanting to introduce these topics into the classroom. And if you can read by the quote, a lot of teachers, or some couple teachers that we have tested and used this application with, they really loved it, and they can't wait to start integrating it into the classroom. And so, although it's a lightweight application, I would like to thank everyone on the slide who made this possible. Specifically, we collaborated with Course Cata through, thankfully, a grant from the Bill Gates Foundation, and we're able to then engage with developers from QuantStack and QuantSide, as well as open teams, in order to get this application into the browser. And so if you want to read more a little bit about the technical aspect of getting R in the browser, you can obviously access this blog by Isabella. Here's the QR code. So I'll give you all a few minutes. Okay, great. And then Agria is currently also working on another blog post about what Jupyter Everywhere is trying to achieve and what they did to create the front-end extension. And so if you currently want to access and test out Jupyter Everywhere, please do. Obviously, with tech development, it's not perfect, but it works. And so if you have any questions or any comments or want to talk about how we can start integrating low-code, no-code technology into the classroom, please reach out to either me or Dash. But thank you.